Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set one of 10 good problems on the chapter of cubes and cube roots. Uh, this video is part of the playlist Maths 8 HOT. HOT stands for High Order Thinking Problem, where I come up with 10 good problems of a particular chapter every now and then. So the idea is to keep on providing sets of 10 good problems of a particular chapter as the chapters are completed from the playlist CBSE 8 CBSE Maths R8 RS Agarwal. So recently I have just completed the chapter of cubes and cube roots, and so this is the first set of 10 good problems on the chapter. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's solve the first 10 good problems on the chapter of cubes and cube roots. Okay, so I have the 10 good problems on the left hand side on the chapter of cubes and cube roots, and on the right hand side I will solve the problem. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution for your future reference. But it is always recommended that you try to solve the problems yourself first. Give multiple attempts. Only when you are stuck, if you cannot solve it, then you can see the this solution video as a reference. So let's start solving the problems. I hope the problems are visible properly. Okay. The first problem is the sum of cube root and reciprocal of cube root of a perfect cube is 17 by 4. The sum of cube root and reciprocal of cube root of a perfect cube. So let the perfect cube be x. Let the perfect cube be x. So this implies, what do we have? It is saying that the sum of cube root and reciprocal of cube root. So cube root of x is equal to, so now it is given that sum of cube root, that is cube root of x, plus the reciprocal of cube root of a perfect cube, that is 1 by reciprocal of cube root of x is 1 by cube root of x. This is given to be 17 by 4, and we have to find the square root of the number. That is, we have to find the number we have assumed to be x, which is a perfect cube. So we have to find the square root of the given number, that is square root of x. Okay. Now in this kind of problem, you always first try to see whether you can express the right hand side given rational number. You can see that the rational number on the right hand side is an improper fraction, and when we convert it into a mixed fraction, we get 4 and 1 by 4, which is equal to 4 plus 1 by 4. Now you can match on the left hand side, 17 by 4 is cube root of x plus 1 by cube root of x. So if you match, this will imply that a cube root of x will be equal to 4, or you can say 1 by 3. No, it is not necessary. We can directly say that since cube root of x plus 1 by cube root of x is equal to 4 plus 1 by 4, we can obviously say that cube root of x is equals to 4, because if we have something like a plus 1 by a is equal to, let's say, 2 plus 1 by 2, we can always say, now a plus 1 by a, a is a whole number obviously, and 1 by a is a definitely a fraction, or a proper fraction. And also we can see that if we have a plus 1 by a equals to 2 plus 1 by 2, then from comparison we can always say that a equals to 2. So we have square root of cube root of x equals to 4. This implies uh, if you take cube, this implies, so we have cube root of x equals to 4. So if I take cube on both sides, I will get 4 cube. This implies x is equal to 4 cube. Now why cube root of x? Always remember that a cube root of a number, if you take the cube root of a number, let's say a is a number, positive number, you have its cube root, and if you take the cube of the cube root of a, it will always be a. So we have x equals to 4 cube. This is 4 cube is equal to, we can say, we have to find the square root of x. Okay, so we have found x to be equals to 4 to the power 3. Now this implies square root of x is, we know, is x to the power 1 by 2. Now this is equal to, we know x as 4 to the power 3, and this whole raised to the power half. Now this is equal to, we can say, 4 raised to the power half and this whole raised to the power 3, as we can interchange the two levels of power, that is x to the power m and then this whole raised to the power n is equal to x to the power n and then this whole raised to the power m. Now what is 4 to the what is 4 raised to 4 to the power half? We can say this is equal to square root of 4 3, because we know that square root of any number is equal to that number raised to the power half. So this is equal to, square root we know is 2, so this is equal to 2 cube, this is equal to 8. So 8 is the value of the square of the given number. So the correct choice is C. C is the correct choice. Okay, let's do problem number 2. The least number to be multiplied with p to give a perfect cube is 15, and the least number to be multiplied with q to give a perfect cube is 45. Then the least number to multiply with pq to give a perfect cube is, so it is given that p is a number, p and q are some numbers. The least number to be multiplied with p to make it a perfect cube is 15. Okay, now so it is given that p multiplied by 15 is a perfect cube. Is a perfect cube. Now this implies now what is p? P is 3 multiplied by 5 is a perfect cube. Now this implies that p must be a form, the number p must be of the form is a perfect cube. Okay, so p must be of the form the least number, p must be of the form some x apart from 3 and 5, so definitely 3 and 5 is a prime factor of p, and apart from 3 and 5 it can have any other any other any other prime factors. Now, since it is given that 15, which is 3 multiplied by 5, is the least number to be multiplied with p to make it a perfect cube, this will imply that p must have the factor p must have the factor 3 to the power 3 to the power 3m plus 2 for some n natural numbers, because since we have to multiply the p with 3, and obviously then it is making some triplet. It will complete a triplet of 3. So that means that the number p is lacking two factors of the number p is lacking the number p must be if the must be of the form if the number p must have the factor which is the power of 3, and the power must be 3 to the 3m plus 2, because it is 3m 3 to the power 3m plus 2, because this is nothing but 3 to the power 3m. It might be having some triplets of 3, 1 or 2 or 3 or 4, any number of triplets of 3, and that is expressed as 3 to the power 3m, and it must have 3 square, that is 2 3 as factors which are not part of any triplet, and only then that is because and hence when we are multiplying with 15, we are having a 3 as factor in 15. When we are multiplying 3 with 3 to the power m multiplied by 3 square, the 3 square and 3 will make another triplet, and then it will be a perfect cube. So p must have the factor 3 to the power 3m multiplied by 3 square, and also similarly p must have the factor 5 3n plus 2, because we have to multiply 5 with p to make it a perfect cube. This means all the factors of p, all the factors of 5 in p, even expressed as power, is of the form 5 to the power 3n plus 2, where n is some other natural numbers, and this is 5 to the power 3n multiplied by 5 square, and this 5 square is not part of any triplet of 5s. That is why we need another 5 to make it a perfect cube, and hence since the 15 is the number that need to be multiplied with p to make it a perfect cube, we can say that p must have p must have 3 to the power 3m plus 2 multiplied by 5 to the power 3n plus 2 as a factor. So similarly we will have, it is also given that q, the least number to be multiplied with q to make it a perfect cube is 45. So q, it is given q multiplied by 45 is a perfect cube, because 45 is the least number which when multiplied with q will give a perfect cube. So we can say that q multiplied by 45 is a perfect cube. So q multiplied by 45 is nothing but q multiplied by 9 into 5. This is equal to q multiplied by 3 square and 5. So this will imply that this will imply that Q must be of the form must be. So this means that Q there is a factor in Q, there is a factor 3 in Q which is not part of any triplet, and only then when we are, if we multiply it with 3 square, it will form a triplet, and hence Q will become a perfect cube. So Q must have a factor 3 which is not part of a triplet, and hence Q must have the factor, you must have the factor 3 to the power 3q plus 1, because there will be one factor of 3 in q which will not be a part of any triplet, because why we can say that, because we can see that 3 into 3 that is 3 square need to be multiplied with q to make it a perfect cube. Okay, so this is nothing but 3 to the power 3q multiplied by 3. So we can say that q must have the factor 3 to the power 3q plus 1, because only when when we multiply the list number, that is 45, which is having a 3 square as a factor, with 3 to the power 3q plus 1, then it will make a perfect cube, because as 3 to the power 3q plus 1 multiplied by 3 square is equal to 3q plus 3, that is 3 to the power 3 times q plus 1, which, since the power is a multiple of 3 into q plus 1, so these 3 to the power 3 into q plus 1 will form a triplets. So from the fact that 45 is the least number that need to be multiplied with q to make it a perfect cube, we can say in the 45 is, if we factorize 45, it is 9 into 5. So in 9 we have 2 3s. So definitely there must be 1 3 factor in q which is not part of any triplet. Hence we can represent q as the factor of 3. We can represent the factor of 3, all the factors of 3 as 3 to the power 3q plus 1. So also q also, since 45 is 9 into 5, we can say q must have the factor 5 to the power 3r plus 2, because in 45 there is 1 5, so which means the q needs 1 5 to make all its 5s form triplets. So which means that q must be having the factors of 5 which whose power is of the form 3r plus 2, because only when, if you multiply 5 with 5 to the power 3r plus 2, it will be, since if you multiply 5 to the power 3 plus 2 with 5 again, this becomes 5 to the power 3 into r plus 1. So 5 to the power 3 into r plus 1 can form perfect triplets of 5. So we get that P is something like a cube, and it will have 3 into 3 to the power 3m plus 2 multiplied by 5 to the power 3n plus 2, and where a will be some natural number, and a cube is forming a triplets of some natural numbers. Similarly, q will also be of the form p cube, where b is some natural number, and the factors of 3 and 5 in q must be of the form 3 to the power 3q plus 1 multiplied by 5 to the power 3r plus 2. Okay, So now this implies what is PQ? PQ becomes AB whole cube, and AB whole cube will form triplets, and we have 3 to the power mm, we have 3 to the power, if we multiply all the powers of 3, that is 3 to the power 3m plus 3q plus 2 plus 1, and we have 5 to the power. If we add up the powers of the 5, we get 3n plus 2 plus 3r plus 2. So this is equal to AB whole cube multiplied by 3 to the power, we have 3 times m plus q plus 1, where m, n, q, r are all natural numbers, and we have 5 to the power 4. So we have 5 to the power 3 5. So we have 3 n plus r plus 1 and plus 4 1. Square. Let me quickly check if I did it correctly or not. The p must have the factor 3 to the power. Now the least number to be multiplied with p is 15, which is 3 multiplied by 5. Okay, since we have 1 3 and 1 5 in 15, so definitely p must have the factor 3 to the power 3m plus 2. Okay, and p must also have the factor 5 to the power 3n plus 2. Okay, 3n plus 2, and q for q the least number to be multiplied is 45, which is equal to 9 into 5, which is equal to 3 square into 5. So definitely from this we can say that q must have the factor 3 to the power 3q plus 1. Okay, and q must also have the factor 5 to the power 3r plus 2. 3q plus 1, 5 to the power 3r plus 2. Okay, so now we can say that the number p should be of the form a cube, where a is some natural number, a cube multiplied by, it must have the factors of 3 and 5 in powers as 3 to the power 3m plus 2 multiplied by 5 to the power 3n plus 2, and q must be of the form b cube for some natural number b, and it must have the factors of 3 and 5 and powers as 3 to the power 3q plus 1 and 5 to the power 3r plus 2. Okay, plus 1 5. Okay, so now if we multiply PQ, we are asked to find the least number to multiply with PQ to give a perfect cube. So if we multiply PQ, we are getting AB whole cube of AB. Now AB will also be a natural number, it will form triplets, and the powers of 3 is will be 3m plus 3q plus 2 plus 1, 2 plus 1. Okay, which is 3 into m plus q plus 1. Okay, and the power of 5 will be 3n plus 2 plus 3r plus 2, which is equal to okay, so we are having this. Okay, so this is equal to AB q into 3 into, we can say, as m plus 3 to the power 3 into m plus q plus 1, can also be written as 3 to the power m plus q plus 1 and this whole raised to the power q. And we have 5 to the power 5 to the power 3 into n plus r plus 1, and we have the plus 1 that is multiplied by 5. Now this expression will form triplets perfectly. This expression will form triplets of equal factors perfectly. This expression will form triplets of equal factors perfectly. So this 5 is the only factor which will not be a part of triplet in the number PQ. So the least number to be multiplied the least number to be multiplied to PQ to make it a perfect cube will be equal to, we have to multiply with 5 what we can multiply with 5 to make it a perfect cube, that is a triplet, the least number, and that is 5 square. So 25 should be the least number that need to be multiplied with PQ to make it a perfect cube, but it is not in the choice. It is not in the choice. I might have done some little bit of mistakes. So P 15 is the least number that need to be multiplied to make P a perfect cube. So 15 is 3 into 5. Okay. Now this means that P P must be having a factor of 3 whose power will be of the form 3m plus 2 3m because it could there could already be some triplets of 3. So 3 to the power 3m will make m number of triplets. Now 3m plus 2 because it must be having it must be having 2 3's, which is not part of a triplet. That is the reason when 15 is multiplied with P, it is making a perfect cube. That is the 2 left behind factor of 3 in P is making a triplet with the factor of 3 in 15. So P must have the factor 3 to the power 3m plus 2. Similarly, by similar logic, P must have the factor 5 to the power 3n plus 2, because for some here m and n are natural numbers. That is because in the number 15 the factor is 5. The factor 5 is occurring 1 times. So definitely the number P might have 2 factors of 5 which is not part of any triplet. So the factor of 5 in P must be of the form 5 to the power 3n plus 2. Okay. So P must have 3 to the power 3m plus 2 multiplied by 5 to the power 3n plus 2 as factor. So by similar logic, we will have Q must have the factor since 45 is the least number to be multiplied with Q, and 45 is 9 into 5. 9 means 3 square. So 3 square into 5. So this means the number Q must have a factor of 3 which is not part of any triplet. So the powers of factor 3 in Q must be of the form 3 to the power 3q plus 1, where Q is the natural number. Q is a natural number. Okay. And since 45, the 5 is the factor of 45, this means that Q must also have the factor of 5, which when expressed as a power of 5 will be 5 to the power 3r plus 2. 3r plus 2, because Q must have 2 factors of 5 which is not part of any triplet. So the factor of 5 in Q must be 5 to the power 3r plus 2. So we are getting P is of the form a cube multiplied by 3 to the power 3m plus 2 multiplied by 5 to the power 3n plus 2, and Q must be of the form B cube multiplied by 3 to the power 3q plus 1 and multiplied by 5 to the power 3r plus 1, 3r plus 2. So if you multiply PQ, we get AB cube, and the power of 3 is 3 into m plus q plus 1. Now the power of 3 is a multiple of 3, so it will form a perfect triplets. But the power of 5 is 3 into n plus r plus 1 plus plus 1 square 4. So so in a PQ, the factor we are having the factor of 5 as 5 to the power 3 into n plus r plus 1. Now this thing is a perfect cube, so it will form perfect triplets. So this factor we can see is only left behind, which is not part of any triplet. So definitely PQ must be multiplied by 5 square, that is 25, to make it a perfect cube. And 25 is not in the given choice. Maybe I did some mistake in making the in writing the problem, either in the choice is not in the problem statement. I will verify that later on. So I'm putting a question mark and moving on to the next question. I hope you got the idea and the approach of solving the problem. Okay, let's do problem number 3. Problem number 3 says that for natural numbers a and k, the number a to the power 3k is always a perfect cube. So we know that any number of the form a to the power 3k, where a is the natural number and k is also some natural number, will always be a perfect cube. It will always be a perfect cube because the power is a multiple of 3. So any natural number raised to a power which is multiple of 3 is always a perfect cube, because we can always write it as a to the power 3k, we can write it as a to the power k, and this whole raised to the power cube. So definitely this a to the power 3k is a cube of a to the power k. So a to the power 3k is a perfect cube. Okay. Now it says if a to the power 3k is also a perfect square, then which of the following is necessarily true? It is also saying that a to the power 3k is a perfect square, is a perfect square. If this is so, this will imply that square root of a to the power 3k is a natural number, is a natural number. If a to the power 3k is to be a perfect square, then we must have the square root of a to the power 3k to be a natural number. Now, what is a to the square root of a to the power 3k? Square root of any number is square root of any number, non-zero number, is equal to that number raised to the power half. So we can say a to the power 3k was the number. This raised to the power half is a natural number. Now this implies what is a to the power 3k, and again raised to the power half. This is equal to a to the power 3k multiplied by half is a natural number. So this implies a to the power 3k by 2 is a natural number. Now when can a to the power 3k by 2 will be a natural number? It is asking then which of the following is necessarily true. That is, all the choices are some condition about k. Now some condition about k. Now so if a to the power 3k by 2 has to be a natural number, this will imply that the power 3k by 2 must be a natural number. Must be a natural number. Now this will imply that 3k by 2 must be a natural number. This will imply that k by 2 must be a natural number. So this implies k has to be a multiple of 2. K has to be a multiple of 2. This implies K is even. K is even. So the correct choice is C. C is the correct choice. It is given that then which of the following is necessarily true. Necessarily is true. Now, if for the other choices k greater than 0, any value of k greater than 0 will not make k by 2 a natural number, because k greater than, if we consider k as 3, which is greater than 0, then 3 by 2 will not be a natural number. So k by 2 will only be a natural number when k is divisible, k is a multiple of 2, and k is a multiple of 2 means k is an even number. Okay, let's do problem number 4. It is given for non-zero rational numbers x by y and p by q. If cube root of x by y equals to p by q, then which of the following is not correct? Okay, so it is given that cube root of x by y is equal to p by q, where x and y, x by y and p by q are non-zero rational numbers. Okay, then which of the following is not correct? Now from this we can straight away say that since cube root of x by y is equal to p by q, we can say that cube of p by q is equal to x by y. Okay. Now let's see all the choices and try to verify whether which one is correct or not. So what is choice A? Choice A is saying x cube is equal to y p cube. Now from this that we have got from the given fact that cube root of x by y is p by q, which will mean that cube of p x by y is cube of p by q will be x by y. So x by y is equal to p by q whole cube. Now p by q whole cube, p by q whole cube is equal to p cube plus p cube divided by q cube. So this implies x by y is equal to p cube by q cube. This implies x cube, by doing cross multiplication we get x cube is equal to y p cube. So the choice A is a correct choice. Choice A is a correct statement. That is, the equality statement is correct. That is, x cube is equal to y p cube. So this is not an incorrect statement. We have to find the choice. We have to select the choice which is not correct. Okay. So let's see what is B. B is saying that p is equal to cube root of x and q is equal to cube root of y. Okay. Now from this fact, we can say the left hand side can be expressed as cube root of x by y is equal to cube root of x divided by cube root of y. So we get cube root of x divided by cube root of y is equal to p by q. But this does not imply that p is equal to cube root of x and q is equal to cube root of y. Because if it is given, the concept is, if it is given a by b is a rational number, if it is given to be equal to c by d, this does not imply, this symbol means does not imply that a equals to c and b equals to c. We cannot say that a equals to c and b equals to d if we know that a by b equals to c by d. Similarly, we cannot say cube root of x, if cube root of x divided by cube root of y is equal to p by q, we cannot say p equals to cube root of x and q equals to cube root of y, because uh, because the choice B is a false, is an incorrect statement, because take an example. Let's say cube root of uh, uh, 16 by 54, cube root of 16 by 54, that is let x by y is equal to 16 by 54. Now cube root of this will imply cube root of x by y is equal to cube root of 16 by 54. This is equal to, if you do cancellation, we get 8 by 27, and this is equal to, now we can say cube root of 8 divided by cube root of 27, this is equal to 2 by 3. It is 2 by 3, whereas as you can see, so cube root of 16 by 54 is equal to 2 by 3. So we can, and so also, so this you can see that 2 is not equal to cube root of 16. 16 is not a perfect cube. Also you can see 3 is not equal to cube root of 54. So that is the reason the choice B, where it is saying p equals to cube root of x and q equals to cube root of y, this is an incorrect statement. So hence the answer is choice B, because that is the incorrect statement. Okay, let's do problem number 5. Let's do problem number 5. It is, problem number 5 says, how many perfect cubes are there between 1 and m, where m is a perfect cube? So between 1 and m, how many cubes are there? How many perfect cubes are there between 1 and m, where m is a perfect cube? Okay. Now m is a perfect cube will imply cube root of m will be a natural number. Is a natural number. Now it is asking that how many perfect cubes are there between 1 and m, where m is a perfect cube. So let since m is a perfect cube, let cube root of m is equal to n, where n is a natural number, because m is a perfect cube. So the cube root of m will be a natural number. Let's say that be n. So we have we have to find all the perfect cubes between 1 and cube root between 1 and m, and we have assumed that cube root of m is equal to n. Now definitely all the perfect cubes that are between 1 and m means let y be a perfect cube between 1 and m. That is y lies between 1 and m means y is greater than 1 and less than m. Let y be a perfect cube between 1 and m. between 1 and m. So y is lying between, so we have to find the number of perfect cubes that lie between 1 and m. So we are considering, let y be a perfect cube between 1 and m. Now, so this implies we have to so how many such y can exist between 1 and m, between 1 and m. So we can say that if we consider all the y to be perfect cubes that lie between 1 and m, we can say that cube root of y will also lie between 1 and cube root of m. Cube root of y will also lie between the 1 and cube root of m. We have to find all the possible number of y's, all the possible y's, where y is a perfect cube we have considered that lie between 1 and m. So if y is a perfect cube lying between 1 and m, we will have a 1 greater than 1, y greater than 1 and less than m. So this will also mean that the cube root of y will also lie between 1 and the cube root of m. So now we have to find how many cube root of y's can exist. Now cube root of y is a natural number. Cube root of y is a natural numbers. So now we have to find how many y cube root of y can exist. How many are there? How many cube root of y are there between 1 and cube root of n? Cube root of m. Cube root of m is a natural number. That is if cube root of y is equal to z. If we assume that cube root of y is z, then we will have z must lie between 1 and n. And what is n? N is the cube root of m. N is the cube root of m, and n is basically cube root of n. So how many? So now the question is how many natural numbers you can find, or how many numbers you can find between 1 and n. That is the number of we can say that is the number of z that will lie between 1 and n, where n cube is equal to m, where n cube is equal to m, and obviously z cube is equal to y. And we were asked to find how many perfect cubes, that is how many y's are there between 1 and m. Now this is and the answer is how many cube root of y are there between 1 and cube root of m. That is, if cube root of y is equal to z, then we will have z will lie between 1 and n. This implies number of perfect cubes between 1 and m is equal to number of natural numbers between 1 and cube root of m. This is equal to cube root of m minus 1 and minus 1. That is cube root of m minus 2, because how they are between a and b, we know, or you must know the fact that between the natural numbers, or the natural numbers a between or integers between a and b, integers there are b minus a minus 1 integers. There are b minus a minus 1 number of integers between the two integers a and b, where a is less than b, where uh, where uh, where a is less than b. So similarly, now if we have to find all the natural numbers z, and which will lie between 1 and n, it will be n minus 1 minus n minus 1 minus 1, which is n minus 2. And what is n? We have already assumed n to be cube root of m. So the answer is cube root of m minus 2. So the correct choice is D. D is the correct choice. Okay, let's do problem number 6. It is given that if x and y are integers such that x square is greater than y square, then which of the following is correct? It is given x square is greater than y square, then which of the following is correct? So let's see one by one the choices. It is saying x greater than y. Which of the following is correct means which of the following has to be true for all values of x and y, where x square is greater than y square. So we are given x square greater than y square, and we don't know what values are x and y have, whether they are positive or negative. We are just given that x square is greater than y square, and we know that x square and y square both are positive numbers. So if x square is greater than y square, can we say x is greater than y? No, we cannot say. This is a wrong statement. This is a wrong choice, as you can see that minus 3 square is greater than minus 1 square. Minus 3 square is 9 and minus 1 square is 1. So 9 is greater than 1. But we have minus 3 less than minus 1. Minus 3 less than 1. So this is our example where x, if you consider x as minus 3 and y as minus 1, so we are getting x square greater than y square, but we are not getting x greater than y, and we are getting x less than y. So the choice A is not necessarily always true. So it is not a correct statement. Correct choice. Choice B is x cube is greater than y cube. X cube is greater than y cube. Now, if you take the same example, this will also be not necessarily true all the time when it is given x square greater than y square. If you take the same example, x as minus 3 and y as minus 1, you will see minus 3 square is 9, which is greater than minus 1 square 1. But you can see that minus 3 cube is less than minus 1 cube. That is, we can say that minus 3 cube is minus 27. Minus 27 is obviously less than minus 1 cube, which is minus 1. So if we just consider the example x as minus 3 and y as minus 1, the choices A and B, it will be found that choices A and B are incorrect. What about choice C? It is saying that cube root of x square is greater than cube root of y square. Now this is true because x square and y square are both a positive number. We have cube root. Okay, so x square and y square are both positive numbers, and cube root of a positive number is a positive number, and cube root of a negative number is a negative number. So therefore, if you have x square greater than y square, this will imply since both x square and y square are positive numbers, we can say that if you take, we can say that the cube root or any power you take, if you take the power of, the power of 1 by 3 power means cube root must be greater than if I take the power of 1 by 3 on both the sides, the inequality will remain same. So that is, if x square is greater than y square, and we clearly know that x square and y square are both positive numbers, then the cube root of x square has to be greater than cube root of y square. So choice C is the correct statement. Choice C is a correct statement. And what about D? D is saying x less than y. X less than y. No, it is not necessarily true that x will always be less than y if we have x square greater than y square, because let's say x equals to 2 and y equals to 1. We clearly have x square is equal to 2 square is equal to 4 greater than 1 square. So this is also a wrong statement. So the correct choice is choice C. C is the correct choice. Okay, let's do problem number 7. An equation is given and we have to find the value of x. The equation is 7.2 divided by cube root of 0.729 is equal to x cube divided by 2 cube. Okay, the right hand side we can say it is x cube divided by 2 cube is, we can say, write it as x by 2 whole cube. Now we can only solve this problem if somehow we can convert the left hand side as an exponential term with the power 3, and the base will be some constant, and then we will equate the base on both the sides. So the LHS is, we can see LHS is 7.2 and cube root of 0.729. This decimal, if we convert it into fraction, it will be 729 by 1000. So we have this equal to x by 2 cube. So this implies 7 by 2 and the cube root of 729 by 1000. We can see the fraction 729 by 1000, both the numerator 729 and the denominator 1000 are perfect cubes. So we can write it as cube root of 729 divided by cube root of 1000 is equal to x by 2 whole cube. So this will imply 7 by 2 divided by cube root of 729 is 9, and cube root of 10, 1000, cube root of 1000 is 10. Okay, so this is equal to x by 2 whole cube. This implies, if you simplify the left hand side, it is 7.2 multiplied by 10 divided by 9 is equal to x by 2 whole cube. So this is equal to this is equal to 7.2 into 10 is 72, and 9 is equal to x by 2 whole cube. 72 by 9 is 8. So 8 is equal to 2 cube. So this implies x by 2 whole cube is equal to 2 to the power 3. We are having the base same, we are having the power same, so base must be also same. We have x by 2 is equal to 2. This implies x equals to 2 into 2 equals to 4. So the value of x is 4, and the correct choice is choice A. Let's do problem number 8, which is a simplification problem. Problem number 8, we have 4096 raised to the power 1 by root 3. 1 by root 3 is raised to the power square root raised to the power 2. Okay, so we are having so what we are having is the number, if you visualize it, if you break it down in the form as we are having something like 4096 to the power x, where x is equal to 1 by root 3, this whole raised to the power square root of 2, and the square root of 2, the power square root of 2 is again raised to power 2. So what is x? If we simplify x, x becomes 1 by root 2, 1 by root 3 whole raised to the power is nothing but root 2 square, and root 2 square is 2. Square of any square root is the same number. So we have this equal to 1 by root 3 whole square. This is equal to 1 by 3. So x is equals to 1 by 3. So therefore, 4096 raised to the power x, which is 1 by 3. So basically we have to find the cube root of 4096, which is equal to, if you do the prime factorization, we have, if you divide by 4, I have 1, 0, 2, 4, and again 4, 2, 8, 5, and 6, and again 4, 64. Okay, so this is equal to cube root of 4096 is nothing but 4 cube multiplied by 64. This is equal to cube root of 4 cube multiplied by 4 cube. This is equal to cube root of 4 to the power 6. This is equal to 4 to the power 6 by 3. This is equal to 4 to the power 3, which is equal to 64. And we are not having the choice as 64. Let me see, I might have done something wrong. The number can be expressed as 4096 to the power x, where x will be 1 by root 3 raised to the power square root, and square root again is square root is again raised to the power 2. So square root of 2 raised to the power 2 is 2. So we have 1 by 3 raised to the power 2, that is square of 1 by root 3, which is 1 by 3. Okay. Now we have to find 4096 raised to the power x, and x we have found to be 3. X we have found to be 1 by 3. So we have to now find 4096 raised to the power 1 by 3, which is nothing but cube root of 4096. Now what is cube root of 4096? We divide by 4, we have 10, 24. Okay. If we again divide by 4, we have 4 to 8, 5, and 6 to 56. Okay. And then again we divide by 4, we have 60, 64, 24, and 4, 64. So 4 cube, so it is coming out to be a cube root of 4 cube multiplied by 4 cube. This is cube root of 4 to the power 6. That has to be, I'm sorry, this is not 3, but this is 2. This is 2. So 4 square is 16. So the correct choice is B. The correct choice is B. Okay. Let's do problem number 9. It is given that x to the power y to the power z is equal to 2 to the power 8. Then find the maximum possible value of x into y into z, where x, y, z are all greater than 0. It is given that x, y, z greater than 0. We know this. Now what can the possible values of x, y, and z be such that x multiplied by y multiplied by z will be maximum? Now the right hand side term is 2 to the power 8. Let us first find out how we can express this 2 to the power 8 in the form of x to the power y to the power z. Now 2 to the power 8, if we consider, if we consider 2 to the power is nothing but 2 to the power 2 multiplied by 2 multiplied by 2. So this is equal to 2 square multiplied by 2 square multiplied by 2 square. This is nothing but 4 cube, which is 4 cube. No, 2 to the power 8. 4 8. Okay. This is 2 square. Sorry, this was wrong. 2 to the power, we have 2 to the power, 2 to the power, the power is 2 into 2 into 2. Now, okay, one thing, let's see how we can, how differently we can express the number 2 to the power 8 as x to the power y to the power z. Now, 2 to the power 8 can be considered as 2 to the power 8, and the number 8 can be always written as 8 to the power 1. Any number x is equal to x to the power 1. So we are having 2 to the power 8 is equal to, we can write 8 as 8 to the power 1. So over here we can see x is equal to 2, y is equal to 8, and z is equal to 1. So this implies if we express 2 to the power 8 as 2 to the power 8 only, we can say that x multiplied by z multiplied by y, that is xyz, is coming out to be 2 into 8 into 1. 2 into 8 into 1, which is 16. Let's see how we can express 2 to the power 8 in a different way. Okay, so we know that 2 to the power 8 means 2 to the power 2 multiplied by 2 multiplied by 2. So this is equal to 2 square, this whole raised to the power 2 multiplied by 2. So this is equal to 2 square is 4. So 4 raised to the power 4 raised to the power 4 raised to the power 8. 4 raised to the power 4. 4 raised to the power 4. So 2 to the power 8 can also be written as 4 raised to the power 4, which is equal to 4 raised to the power 4. 4 can be written as 4 to the power 1. So over here we have expressed 2 to the power 8 as x to the power y to the power z, where x is equal to, so over here you can see x is equal to 4, y is equal to 4, and z is equal to 1. So this implies x, y, z is equal to 16. This 16. What are the different forms we can express 2 to the power 8? Now, 2 to the power 8 is 2 to the power 2 into 2 into 2. Now 2 to the power 8 is 4 to the power 4. Now this is equal to the actual value in integer is 2 to the power 8. The value in integer is 4 to the power 4. This means 4 square to the power square. This is equal to 16 square. So 2 to the power is nothing but 16 square, which is equal to 256. 256. Now the number 2 to the power 8 is 256. Now 256 can also be written as 256 to the power 1. Any integer raised to the power 1 is always equal to that integer. Now this can also be expressed as the number 250, it is 256 to the power 1. Now the power 1 can also be expressed as the power of 1, that is 1. So in this case, x is equal to 256, y is equal to 5, and z is equal to 6. x is equal to 256, y is equal to 1, not 5, y is equal to 1, because it is 256 raised to the power 1 raised to the power, and that power is 1 raised to the power 1. So y is 1 and also z is 1. So this implies x multiplied by y multiplied by z equals to 256. So I think 256 is the maximum value of x, y, z. So the correct choice is C. Let's do the last problem. It is given that cube root of 3 times cube root of x minus 1 by cube root of x is equal to 2. Then it is given that this equation is given, this value is given. Then we have to find the value of cube root of x minus 1 by cube root of x. Now, if we take cubing both sides, we get cube root of 3 into cube root of x minus 1 by 3 cube root of x, and this we have this when we take cube becomes this is equal to 2 cube is equal to 8. Now this implies on the left hand side becomes 3 into 3 cube root of x minus 1 by cube root of x is equal to 8 So this implies 3 into cube root of x minus 1 by cube root of x is equal to 8 by 3 So the correct choice is A. So this brings to an end of solving the 10 good problems of set 1 on the chapter of cubes and cube roots. This set of problems I hope will be beneficial for you to evaluate your understanding on the concepts of cubes and cube roots. If the video was beneficial, then please like it, share it with your friends, and also please do not forget to press the bell icon so that you will be notified by my future videos. Please watch out the playlist CBS Maths 8 Hot, where I will keep on uploading and solving 10 good problems from all the chapters as and when I will be completing them in the playlist CBSE Maths 8 R.S. Agarwal. So stay tuned for the next set of problems, that is set number 2 on the chapter of cubes and cube roots. So thanks for watching, and until the next video, take care and bye.